Hello, my name is Peter Gauguin. I'm with GCTS, and today I'm going to be going through the Coreflood Cell system that we have assembled here. So within the system, we're going to be dealing with pressure. We're going to be dealing with a few other things here that we want to make sure anybody working with the system is taken care of in terms of personal protective equipment. So we always recommend wearing safety glasses, lab coats, and any kind of gloves that you might want to have in place just to make sure that you're protected as you're working with the equipment. So what I'm going to do now is go through a description of each one of the components so you can understand what the capabilities of the test system are. So we have a EPVC Model M. This is a 70 MPa or a 10,000 PSI confining pressure cabinet, along with a pore pressure cabinet for also 70 MPa and 10,000 PSI. We also have the ability of collecting and just data acquisition of ultrasonic velocity waves, PNS waves, while we're running the test under pressure conditions. Then we have the Coreflood Cell itself. And within the Coreflood Cell, we're able to insert a test specimen with the dimensions of 5.5 inches length to 6.5 inches length and a 1.5 inch diameter test specimen. So within the test system, using the overburden pressure or the confining pressure and controlling the pore pressure into the cell, we can generate and obviously perform a permeability test. Now, with the permeability test, the way the system is set up right now, we're going to be using the upstream pressure from this cabinet. But we could also, by integrating another one of these cabinets, be able to provide a back pressure so that we could be working with higher pressures with the same differential that's required for permeability testing. So within the Coreflood Cell, there are a number of components I'm just going to outline right now. We have an end piece, which has the ability to make adjustments to the core specimen that's inside. We have connection points here for the pore pressure, which allows us to be able to flow and bleed air out of the pore pressure platens, or the platens with the pore pressure connections. We also have the same thing on the other side, within this side. And also built into each side are ultrasonic velocity crystals, so we can measure P wave and the S wave. And then we've got the connections here for the ultrasonic platens. And then we've also got the connection points for the pore pressure on this side. And on the other side of the Coreflood Cell is the connection point for the confining pressure. And then you can see the inside. And this is where the membrane is going to be inserted along with the test specimen. And then once we assemble everything, we can tighten everything down and be able to go through and start applying the pressures that we need to for the confining pressure and then also for the pore pressure in the system. So at this point, what we're going to do is show you how to insert the test specimen into the Coreflood Cell. So we have the one end piece here that you can see, and it has a series of O-rings to make sure that they're clean and well lubricated because they're going to be going inside of the Coreflood Cell. So there's a membrane that goes along with the system. Now in the membrane, you're going to notice that there's a taper on one side and a flatter edge on the other. Now the flatter edge is the part that goes onto this particular end piece. And then your test specimen, in this case we have an aluminum specimen as a test specimen, just simply mounts down inside and goes all the way to the bottom. Then once we have that in place, we can easily load it into the cell. And there's a vent line on the very top, so you want to make sure that's loose so that any entrapped air is going to get pushed out. Now there's also a notch on either side of the cell and also of the end piece. You want to make sure that those two marks line up because that's how everything is kind of orientated for the ability to make sure the ultrasonic velocity crystals are lined up as well. Okay, so now what we're going to do, now that we've got everything aligned with notches, we're going to insert the first socket head screw and just thread it into place. And then there's a second socket head screw, which we put on the other side directly across. Now you're going to notice that there's a number system on here. And the reason for that is you want to be able to evenly tighten across from each one of the screws, so it's diametrically opposed, so that it evenly carries the end piece into the main body of the Coreflood cell. And then afterwards, we're going to torque each one of those. Okay, so now that we've got the two socket head screws across from each other in place, using a driver, you can rotate evenly on either side, because we have to slide it over top of two O-rings. And you want to just do this evenly so it goes nice and easy in, and then it'll eventually seal on the main body of the Coreflood cell. And after you've gotten the end plate in position, then you're going to be able to install the rest of the socket head screws and torque them down evenly so that the end pieces are in place and ready for pressure testing. And there we go. So now at this point, the end plate is in full contact with the Coreflood cell, and then we're going to be able to install the rest of these socket head screws. Now that we've got all of the 10 socket head screws hand tightened in place, what we're going to do is we're going to perform a torque pattern where we're going to start off with number 1, which is labeled here, and 1 to 2 and 3 and 4 and so on. And we're going to be working with just hand tightened, but you're going to be just giving a good tug on it. And if you wanted a torque value, it would be between 40 and 45 foot-pounds. So I'm going to go ahead and do that, and just nice and evenly all the way around. Now that we've got the one end piece in place, you'll notice that there are two locations here for connecting the ultrasonic velocity crystals. And they're marked as S and P for shear wave and compressional wave. And then we've also got associated cables, which are also marked with S and P. And they just thread on in place. All right, so now that we have that in place, there's also on the other side another end adapter that we have to have in place. So I'm just going to rotate this around here so you can see it. And we also have connection points here for the S and P crystals. So there's an S and P marked here, and there's an S and P marked on the cables as well. So just go ahead and connect those in place. So at this point, we've got the P and the S wave crystals connected, and then we can thread into place the other end piece that we have. And with this, now you'll notice that there's a thread lubricant on here, which is very important. We want to make sure that all threads have this thread lubricant on it so that they don't get damaged or get stuck. So what we do is we thread this in place. And then we basically make contact with the specimen at this point. So this is dead-ended on this side. So anything we do on this side, using a spanner wrench, we're able to apply a little bit of pressure to the specimen assembly. And what that's going to do is allow us to be able to have better ultrasonic measurements. Actually, I've got to go over an O-ring right now, so that's what I'm feeling. So I'm going to keep going until it stops. So there's two O-rings that have to be in place, and there we are. So now I'm up against the specimen so I can make sure that I've given it a good amount of force, because the better the force, the stronger the ultrasonic waveforms are going to be. And then we have this last ring here, this ring nut, and this is a lock nut. So once we've got everything in place, we can also provide a span on this one to lock it in place so that now it's ready for pressurization. So one of the convenient parts of the Coreflood Cell is that we have this end piece which does have a succession of threads which allow for different size specimens. So depending on the length of the specimen, at least within the tolerance of being between 5 1/4 and 6 1/4 inches, we have the adjustment here that allows us to make contact and then be able to tighten down properly on the cell so that the specimen is going to be in good contact for performing the permeability test, as well as obtaining P and S wave velocities. Now that we have everything connected in terms of the electrical cabling, sensor cabling, and the ring assembly on either end for the platens, now we're going to connect up our hydraulic fittings. So we have a confining pressure connection, which works with a quick connect. Just like that. And there's also a bleed fitting on the top. So what you will do is you will turn on the confining pressure cabinet and you would slowly inject fluid through until you see confining fluid coming out of the top. Once that happens, lock it down into place and tighten it with a wrench. So now we've got the confining pressure quick connect fitting in place. We're going to be connecting up the pore pressure fitting. One of the things you want to make sure of is that this ferrule is showing at least one thread, and that's the proper connection methodology for these autoclave or HIP fittings. And then you just simply line everything up and thread it into place. So now that we've got the connections made for the confining pressure and the pore pressure to the cabinet, in the back there's a bleed line, which we want to make sure we drive all of the air out. And then once we've done that, then we can open up these two port fittings here so that we can push the pore fluid through the cell until we see water coming out of both of these fittings. Once that happens, we can say that the specimen is saturated, and then we can tighten up each one of these fittings if we wanted to. But we can just tighten up one of them and then keep the other one open for our permeability test. So that way we'll be able to measure the amount of fluid coming through, and we can use a catch basin here. So once we have a differential pressure across the core, then we'll be able to make the permeability measurements based on the fact that we know what the differential pressure is, we know what the length of the core is, we know what the diameter of the core is. So starting off with the confining pressure, we're able to operate either in manual control, or we can be working in remote control, which means this computer software would be taking over the operation. From here, we can work within either pressure control or volume control. So within this system, we're going to apply this is where you would apply the confining pressure that you would want to start off with. So if I were using manual control, I could go ahead, punch in, let's say 0.5 MPa, and then the system would automatically adjust to that. Now we also have to make sure that all of the air is bled out of the Coreflood Cell. So there's the bleed port on the top, which I pointed out before. You just need to make sure oil is coming out of there, tighten that down, then you can apply the pressure that you would require just at the very beginning of the test. So you can apply the initial confining pressure and then also the initial pore pressure. So this is the pore pressure EPVC, and what we're going to be doing now that we've got a confining pressure on the specimen, then you would be either injecting pressure or volume control so that you could see water flowing all the way through the cell and coming out of the cell through the exit or the downstream pore pressure port. At that point, what you can do is you can apply a very small pore pressure. In this case, I would apply approximately 0.1 MPa of pore pressure and have that set up and ready for the permeability test. So once the pore pressure has been depleted to 0, then you can reduce the the cell pressure by manipulating the front panel of the cell pressure EPVC, and you want to bring it down to 0 MPa or 0 PSI. Once that's in place, then you can put each one of the EPVCs into volume control, and that way it prevents any further injection of volume or pressure buildup within the system. So now that all the pressures have been depleted, the next thing we do is we remove the pore pressure line using wrenches, of course. And you may have a little bit of fluid coming out, so you can just collect that into the little catch tray. And then we can also remove the quick connect fitting for the cell pressure. Just like that. Now at this point, what we're ready to do is we're ready to dismantle the cell. So in order to dismantle the cell, there's a methodology behind it, and we start off actually with this end piece over on this side. So what we do is, using these spanner wrenches, we loosen the collar, and then we actually loosen the whole end piece, and we rotate it around probably about 5 or 6 times, and that should be enough so that it's no longer in contact with the specimen inside. All right, now that we've got the 10 socket head screws pulled out, you're going to notice there are 4 set screws, and these set screws are in place to be able to pull the end piece away from the main body of the Coreflood cell. The reason for that is the friction that's built up with the O-rings that are in place are going to make it just too difficult to be able to pull by hand. So what we do is you tighten these set screws, and it actually, you can start seeing it's starting to push away the end piece from the main body. So what you do is you kind of go across and work its way out so that it evenly is separating the end piece from the main body of the Coreflood cell. So you just go in a little bit so that it doesn't cause it to get misaligned, so that it evenly comes out. All right, I can see the first O-ring developing there, so that should tell me I should be able to pull this off right away. So we have a small catch tray, and you want to have this in place because the confining fluid that's still inside of the cell is going to drip out, and instead of making a big mess, it'll just be contained within the spill tray itself. And as you pull it out, we'll have this like this, and then you pull out the membrane with the specimen. And of course, at this point, you're going to have all of the fluid come out, and it will land in the catch tray, and your test specimen is inside of the membrane. And then you are ready for your next test specimen.